Hello everyone, in this video we will be discussing on the different system design key concepts. Whenever any system we need to design, then at that time we should be aware of these 14 key concepts. So I will be making a separate video to discuss each of these concepts. So in this video we will be discussing on the first concept, that is scalability. So in the scalability we will be discussing on what is scalability, how can a system grow, how to scale a system, and what are the different strategies to scale a system. So first one is, what is scalability? Scalability is the property of a system to handle a growing amount of load by adding resources to the system. And when we call a particular system to be a scalable, a system that can continuously evolve to support a growing amount of work, that system is called as scalable, and it is always recommended to have a system as scalable. uh, and what are the different reasons that here we mention that whenever this to support a growing amount of work, so why the system can grow? So there are several reasons that the system can grow. It can grow because of the several dimensions. The first one is more users. Let's say we have the growth in user base. For example, consider the Amazon application. Whenever there is sale going on, then at that time we can expect the more requests to the Amazon website. So at that time the users more log into the Amazon website and put a request. So at that time the Amazon website should be enough scalable to handle those many number of requests. Second one is more features. For example, consider any application which has just 3 to 4 payment methods, but instead of those 4 payment methods they wanted to add a newly added payment service. So in that way they are adding features to their system, and in that way the system can grow. Third one is more data. As day passes, the amount of data always increases. For example, consider YouTube. Day by day more people are uploading the contents on the YouTube, and it will result in more data. So the YouTube should be enough scalable to handle that much tremendous amount of data, and it should be scalable for that. And fourth one is more complexity. The system's architecture evolves to accommodate new features, scale, or integrations, resulting in additional components and dependencies. For example, consider a simple application which is broken into smaller independent system. So because of the dependencies and components, it will become more complex. And fifth one is more geographies. The system is expanded to serve users in new regions or countries. For example, an e-commerce company launching website and distributions in different international markets. Then next one is how to scale a system. So there are 10 strategies to scale a system. So we will be discussing all these 10 strategies in detail. So first one is vertical scaling. Vertical scaling is a scale up approach where we will add more power to existing machines itself by upgrading servers, more RAM, faster CPUs, or additional storage. And this is a good approach for simple architectures where smaller applications are involved and small amount of data. But it has a limitation, because to particular single system how much amount of resources can be added, that can limit up. That's why this vertical scaling is not recommended for larger architectures. So for larger architectures we will go with the horizontal scaling. It will called as scale out also. It means adding more machines to your system itself to spread the workload across multiple servers, and it is considered the most effective way to scale for larger systems. For example, the Netflix uses horizontal scaling for its streaming services, adding more servers to their clusters to handle the growing number of users and the data traffic. Then third one is load balancing. Load balancing is the process of distributing traffic across multiple servers to ensure no single server becomes an overwhelmed. For example, consider the Google. It employs load balancing extensively across its global infrastructure to distribute search queries and traffic evenly across its massive server farms. Then fourth one is caching. Caching is a technique to store frequently accessed data in memory like RAM to reduce the load on the server or database itself. And it uh, caching improves the response time in significant way. For example, consider the Reddit. It uses caching technique itself to store frequently accessed content like hot posts or any comments which wanted to be served quickly without querying the database each time. So whatever are the contexts which are requested frequently, that will be stored in cache, and instead of firing each time request to the database itself, it will be extracted from the cache and it will become efficient and the response time will be quick. Then the fifth one is content delivery networks. Content delivery networks, it distributes static images, static assets like images or videos to the closer to user itself. So whenever any static data we require, at that time we can use the content delivery network. So instead of let's say this is the original server, this is CDN server, and this is users. So instead of whenever user request any particular data or something, that at that time instead of going that request to this original server, the data will be accessed from the CDN server itself, so that as it is nearby to the user, so it will the response will be quick and it will reduce the latency and result in faster load times. And the example for this is Cloudflare. It provides CDN services and speeding up the website access for users worldwide by caching content in server located closer to the users. Then the sixth one is sharding or partitioning. Partitioning means splitting of the data in or functionality across multiple nodes of servers to distribute the workload and avoid the bottlenecks. And the example for the sharding or partitioning can be considered as Amazon's DynamoDB. It uses partitioning to distribute the data and traffic for its NoSQL database service across many servers, and it will ensure the fast performance and the scalability. Then seventh one is asynchronous communication. Here consider, for example, person A sends some message to the person B. So instead of waiting from the reply from person B, person A continues with his work and that particular message will be in queue. This is called as asynchronous communication. It means deferring a long running or non-critical task to the background queues or message brokers. It will ensure that the main particular application will become responsive always to the users. And the example for this can be considered as Slack. It uses asynchronous communication for messaging. So whenever any particular message is sent, the sender's interface doesn't freeze and it continues to be responsive while the message is processed in the background. Then eighth one is microservices architecture. What microservices architecture does, it just breaks the particular monolithical architecture into smaller and independent services that can be scaled independently, and it will improve the resilience and allows team to work on specific components in the parallel one. And the example for this is like Uber. Uber has evolved its architecture into microservices to handle different functions like billing, notifications, or ride matching independently, and it allows for efficient scaling and rapid development. Then ninth one is auto scaling. Auto scaling means automatically adjusting the number of active servers based on the current load. So manually no need to scale up or scale down the system. Whenever the more requests are there on particular scale day or something, automatically that feature will add the servers, and if requests are less, then it will scale down. For example, Amazon's auto scaling monitors application and automatically adjust the capacity to maintain the steady and predictable performance at the lowest possible cost. Then the 10th one is multi-region deployment. It deploys the application in multiple data centers or cloud regions to reduce the latency and improve the redundancy. An example for this is Spotify. It uses multiple multi-region deployments to ensure their music streaming service remains highly available and responsive to users all over the world, regardless whether means anywhere they are located. Here consider US East 1, US West 2 and US West 1. Here in all these regions it got deployed. So these are the 10 strategies through which we can make our system scalable. That's it. We can discuss the next concept in the next video. Thank you.